Hello. So we're back with the same job, yeah? I don't know if you ever heard about the perfect fold, yeah? You remember this power amplifier? If you don't remember, you'll find a link on the description. You remember I said there, actually the relay was replaced. Okay, the job was collected. 1 day later, the man come back. It's not working. And it's under warranty, yeah? Because obviously we give 3 months warranty. It's not working and it's under warranty. What can be worst? You know, to have a job come back 1 day later. It's kind of terrible. So one more time, what we did, we replaced this relay with a brand new one, okay? But the problem is, the job come back with a different fault. So actually now it's outputting on the speaker around 45 volts, yeah? So if you leave a speaker like a few seconds, the speaker will get burned. Now it's a problem because I didn't fix this fault. But how can I explain to the customer? You know, it's not my fault. Actually, I replaced that bit. And now you come back with different fault. You know, you'll start arguing because it's three months warranty, and he said, no, you fix it. Work 1 day, and it's broken again. So I start searching a little bit about this. I have 4 plus 45 volts on the speaker connection. Let's check together, yeah. It is the most awkward when you fix something, you give back the customer 1 day later is back. It's nothing more awkward. And it's hard to be explained, like, you know, it's not my fault. Okay. The amplifier is plugged. Yeah, good. Let's take the multimeter. This will be a short video. I just want to show you because I found the problem. It's you know, it's not the customer fault, it's not my fault, it's someone else's fault. And on the speaker, yeah, I will plug quickly. Okay, what happened here? Any volts? Volts, power on, short, yeah? Okay, I think I'm not touching these bits. Multimeter, yes. And it's changing on ohms, my multimeter. You know, I'm happy I didn't told you what brand is the multimeter. It's a rubbish. Okay, let's try now. Power on. 45 volts, you can see there. 45. So that's the issue. I have 45 volts on the speaker connection. You know, I will kill any speaker. On our speaker, we just connect the short, and when I hear that, boom, I power off. I knew it's current on speaker. Now, if you understand how the amplifier are working, it's like a perfect balance. Let me switch here. So you see, this is a like a classic amplifier, like something like that. You see, it's a balance, and on the speaker connection, you have nothing, 0 volts. So on the middle point of everything, you see, you have here a half, here a half. On the middle, you should have 0. So on the speaker should be only 0. Now, our schematic is different. I can't find exactly the schematic, but let me explain what I checked. Obviously, anything can be wrong, yeah? So you can have anything. You have if it's on the plus, you have plus on the speaker. Can be this transistor, can be this transistor, can be a lot of things, yeah? Our amplifier is a little bit different. We have this part. It's not the same. But anyway, to understand how the thing works. But here, on the way how the signal is coming, here we don't have this part. So from here, we have a chip, and our chip is this one. Yeah, RC. It's not RC. It's 4558. That's our chip. That's the one. Yeah, this one. So I checked, and on the output of this chip, yeah, on the output, which is pin number 7, I have like 13 volts. We plus, yeah. And I said, you know what? What's wrong here? The chip is dead. And if you check how this chip should work, she'll have plus and minus, yeah. No ground. Ground is different on this amplifier, yeah. So ground is something else. So you have plus and minus. It's a differential voltage. And when I checked, and we can check together, yeah. Okay, what I did more, I short the relay, because the relay, like someone said on the comments, you know, mate, the relay starts actually when the signal, when you input the signal, actually it's powering on automatically, yeah. So the relay is open from a wire from this cable. So I just short the relay. It's more simple, so we don't have to use this board. And what do we have here? Here you can see we have this. It's a power supply. It's plus minus 12. But here we have another power supply, plus minus 15. Okay, so let's check together. This will be interesting. This is the perfect fault. You know, you look on the fault, you look under the microscope, and you can't see it. Yeah. Let me connect the ground. The ground is no minus. The ground is the ground. The ground from the transformer. And but not this multimeter. Okay, let's try this one. Okay, that's good. And we have the two big resistor, and here we should have, let's see, it's everything on. The multimeter is on millivolts. Millivolts. Yeah, that's fine, yeah? Yeah, it's okay, millivolts, because it's no signal. So here, power on. 15, you can see. So after this big resistor, you have a zener connected to ground, 15 volts. It does fine, yeah? So one more time. Plus 15, yeah? So here we have plus 15. My monitor goes off. Okay. And here on the other side, we should have minus 15, yeah? And we have like 0.7, you can see. So obviously the chip is outputting some positive thing, yeah? So the chip is fine, but actually we have a problem with the power supply of the chip. Now if you check the track, and I think I will go closer just for you to see. One more time, yeah? It is the relay, I short the relay. We have a resistor, a big resistor from here, and a big resistor from here, yeah? And after that we have two channels to ground. No, the channel are fine, yeah? The channel is not the problem. I'll go under the microscope so we can see exactly. Maybe you can see the fault. Maybe I can't see it. But maybe you can see the fault. Yeah, this is the perfect fault. Well, let's see. So one more time to understand what's going on here. Yeah, I'm really sorry it's too close, but you'll get the point. Now, here is the relay. You have a plus and minus. I short the relay. And from the relay, you have a resistor. From this point here, is making, here, it's a big power rail, is making plus 15. Obviously, to ground, you have a zener. And on the other side, from here, yeah, you have a big resistor here on this point, and here it's a big power rail which is supposed to be minus 15. So let's check together. Let me connect the probe to ground. 1 second. I don't think I found this kind of fault before. And my multimeter is on something. Okay. I have to change that one, but it's hard to find something on screen. The power button is here. Okay. Okay, let's check together. Here we should have minus 15. You can't see. So it should be minus 15, yeah? Power on. 0.7, you can see on the multimeter. Power off. Now, like how I told you, here you have a resistor, yeah? Look on the multimeter, yeah? So the amplifier is off right now. Look on the multimeter. Look on this pin, yeah? So I will power on the amplifier, and it's 46, minus 46 volts. Here 0.7. You can see here nothing, but here minus 20 because the amplifier is off right now and the capacitor is getting discharged. So here I have like now, let's look, 17, but here nothing. Obviously here will be nothing, here nothing, and all the power rail is dead. So you have an issue from this pin to this pin. Yeah? One more time, let's you see it's already, you can see the voltage there. And it now is touching minus 46, you can see, minus 46. And here 0.7, 0.8. But if you check close the pins, it's like they are soldered. So you have a broken track, or what do you have here? So from here to here, you lose like, you know, like 45 volts, 44 volts. But you can see they are soldered perfect. And I look under the microscope, and I didn't understand how this is possible. That's when you have like a bad solder, but you can't see it, but it's behind of the solder. So actually, if you check, let's check together. So here on the pin we have like minus 12, but on the solder we have 0.7. You can see, look on the multimeter, 0.7, but on the pin it's like minus 12 because the amplifier is off right now, of course. So the problem is around that pin. It looks like it's soldered, but it's not. So it's somewhere inside of this pin. Yeah, this is no solder. Oh, it is solder, but probably got oxidated behind of the solder. You see that? That's funny one, because you can't, if you check, everything is perfect and you say okay, it's okay, but it's not okay. So I'll solder this pin right now. But that's why you have to pay attention to understand how the things works, so you can check. So when I seen that power rail missing, I said, you know what? One, the resistor is burned. Two, the second, the tenor is shorted. And that's all. That's the end of the things. But actually, no, we have a broken nut track. We have a broken solder, which actually is not broken. Doesn't look broken, but it is. But you can easily, you know, you can go mad searching for a fault, which you can't see it. So whose fault is, you know? Because obviously this time I did spend like 1 hour checking everything, disconnecting the transistors, checking things, you know, voltage, try to figure out the schematic. But who fault is? It's not the customer fault. Obviously it's not our fault. That's why when you are doing, look, the solder is not getting on the pin. When you are doing a job like that, always you have to be covered. So you have to charge a little bit extra for things like that. For things when with these kind of faults which you can't explain them, yeah. So I'll solder even the second one, because this you can't explain the customer something like that. So, oh, okay, it was working like one day, but you have a different fault. No, he will not understand. He will say, you know what? I fix it, I pay, and it's under warranty. Fix it again. That's what he will say. So let's try now. Let's try now. So let's say here, power up. Okay, I'm doing something wrong. Or what? No, I'm not touching. Sorry, I'm not touching with the multimeter probe. Power on. 0.8. What? Power on. .9. What? Yeah, I'm not touching, or something else happened here. On 0.9. Wow. Well, I still don't believe. I didn't expect that, so can be a short there. So we have ground. Here must be plus 15. Let me power on. And it is plus 15. Here is supposed to be minus 15. On. And when it's on, it's dropping to 0.9. No, I can't believe. On 0.8. So in this moment, that resistor is actually is burned, or I might send it short. Let's come with the power supply. Let's say on the power supply, let's say 10 volts should be enough. Low current. Ground. Okay. 750 milliamps. No, this is minus. No, should be on this side. Okay, you see, I'm happy I have a low current limit, and it's taking like 10 milliamps with 12 volts, so we don't have a short. You can see that, like 10 milliamps. It's not a short. So actually the problem is the resistor itself. You know which one, yeah? This one. This resistor, 1 kilo ohm. But interesting. Let's take out the resistor. Let's take out the resistor and have a look. So it's not short there, but the resistor is not carrying the power. You know, it's no point checking with the multimeter, because you'll have a surprise to find actually the resistor is okay, but it's not. Okay, let's wait for the solder iron. You see, quite a weird fault. I remember we tested on the pins, and on the pins actually was like minus 45. We soldered the pin and now it's 0. But it's not short there. So let's get the resistor out. Now let's study that resistor. One kilo resistor, it's out. So if we check with the multimeter, let's see, ohms, should be 1 kilo ohm, yeah? Maybe it is. Yes, it is 1 kilo ohm. You can see on the multimeter, it's 1 kilo ohm. So how you explain something like that? How you explain it? It's not easy. So you know your power rail is fine, it's not shorted. It's taking like 10 milliamps. You know the resistor is good. Does that kind of everything is good but it's not working. Let's check one more time, yeah? Minus volts. And we can power on, yeah? On 0.8. So 0.8, and on the other side we have minus. So you see, that's the case when actually the resistor, when you check, is fine, 1 kilo ohm. When it's about to carry current, it doesn't carry anything. Let's replace the resistor with 1 kilo ohm resistor and see if that will fix the problem. We need a power one. Like this is like 2 watts, 2 watts resistor. One kilo ohm. That will be hard. These are low ohms resistors. Low ohms resistors. Wow. It will be funny if we can't find the resistor. Hmm? Where we can find a resistor? That's crazy. Yeah, probably I can't find that kind of resistor because it's a big one, big wattage. Hmm. Yeah. So what's the problem? Yeah, then I can check. Yeah. It's the audio amplifier. Yeah, yeah. You know he come back one day later, yeah? Now I need a resistor, I can't find it. It's ready, it's on charge. We need that resistor. Yeah, let's see these ones. Let's see. Let's see. I found something. 4.7 kilo ohms. Yeah, we can use them on a parallel mode. No, no, that's not okay. This is 100 kilo ohms. 100 kilo ohms. 470 ohms. So we can find if we can find two. Uh, 400. If I can find a second one, 470 kilo ohms, 470 ohms, yeah. But it's not. It's not a second one. A second one. .7. It's too big, but should work. Yeah, should work. Let me remove those resistors. Yeah. .7 and 4.7. Let's use them on the parallel mode. Let's see if it's working. So I'll take this resistor out. I'll use two. Maybe I should buy one. If it's working, we should buy one. But this was the most weird fault On the pin you have voltage, and on the solder you don't have voltage anymore. Okay, the resistors are soldered. Let's check. On 0.7. That's sick. Minus 46. I'm stupid or what? Yes, Soren, you are stupid. Actually, the power relay goes shorted when the voltage is on. So yeah, if I will use the power supply, let's say 14 volts, ground, let's solder the ground. Ground, okay. You see, it's better when you're doing these kind of things to use lower current limit, so you're protected, like on my case. Yeah. So it's taking nothing, yeah? That's good. Nothing. So all what we have to do is to power on the amplifier. On. Yeah, 80 milliamps. No, it's not short. Wow, I can't explain that. 80 milliamps is too much. So now it's taking no power. We can higher the voltage, because we have the tenors there. At some point we will see the tenor protection. Yeah, like now. What's wrong with the tenor? Why is not limiting the current? So that's one tenor, and the second tenor is behind of this, from here to here. Okay, let's leave it 15. Yeah, that tenor is weird anyway. On 80 milliamps. One more time, on 80 milliamps. You know what? Let's use... No, I can't use. That's crazy. That's that kind of fault which will drive you crazy. So I don't get it. Our resistor is good. 80 milliamps is too much. Can be. Can be 80 milliamps over 1 kilo ohm resistor. No, no, should be fine. Should be fine. Should be over 50 milliamps. Wait, man, wait. What I'm doing here? We have 45 volts. 45 volts. Have 1 kilo. And we need the current is 45 milliamps. Wow. So our resistor will carry only 45 milliamps according to the Ohm law. Yeah. So what is taking 80 milliamps? So that's our problem. But it's taking only when it's on. That can be only the chip, yeah? That's bad. So now it's taking nothing because it's off. And when it's on, probably that chip is start working. On 80 milliamps, 70. The chip is dead or not? Yeah, probably. What a waste of time. Yeah, only that can be. Because I can't see why it's taking 80 milliamps. What is the chip current? I see together. It's not saying. Current. So the chip is audio amplifier 200 milliwatts. And it's supposed to take like 6 milliamps, 5 milliamps. With no load. True. Supply current 5 milliamps on 50 volts. Supply current versus temperature is same. 5 milliamps. Yeah, the chip is dead. What a waste of time. I can't believe. I was sure, it's that resistor is the problem. Okay. No, it can't be, it's nothing else what can be here. Because from the truck, yeah, you see that's the power truck. It's taking no power when it's off. That's a sign your power rail is healthy. It's nothing getting the current. And it's going straight to the chip, to the pin number for the chip. It can be only the chip. We have to order the chip now. So whose fault is? How much is this chip anyway? I can find it on eBay? Probably. The chip is like £2. Yeah, that's the chip. Let me check one more time. Yeah, that's the one. With D on the end. This one. £1. It's £1. I can't believe. That's the price of this chip. And mine one it's with D on the end. Okay, I will buy the chip. I will buy the chip and see you next time, yeah? Yeah, probably I have to do one more video about this. Can happen to anyone. Thank you for watching. Like and subscribe if you like the video. And see you later. I was so excited, I said, look, it's a solder. And the pin is fine. On the pin I have voltage, you remember? But not on the solder. I said, you know what? That's the fault. But it's not. See you later. Bye.